integrate x cubed times e to the 5x. Okay, so when we look at that, I notice right away I've got a product here. Right? X cubed times, and then this other exponential function that I understand. Okay, and when I see a product like that, I might think integration by parts. So let's set up an integration by parts here. Okay. Now, I've got sort of an algebraic expression, a nice simple, I'd say polynomial, but it's actually stronger. It's a monomial. It's just a single x to the power 3. And then an exponential function. Now, exponential functions, when I integrate them or differentiate them, they mostly still stay as exponential functions. But if I keep differentiating the x cubed enough times, eventually it becomes a constant, and constants are easier to work with in terms of integration, because constants can come out, right? Okay. So that's sort of the reasoning behind, if we're going to do an integration by parts, we let our u be x cubed. And so our dv would be what's left over here, e to the 5x dx, right? Now, the reason being, well, what's the next step in integration by parts? We've got our u, our dv. What do we declare? We need our du. And so the degree is going to decrease. Right? We'll get 3x squared. And then our dv, well, we can go backwards and get a v. And if you need to, you can do a substitution real quick to get this. But v is going to be e to the 5x all over 5. So integration by parts says, well, you take your u, you take your v, and then minus, and we trade one integral for another. So we haven't actually solved the problem, but now it's v, and then your, I guess there should be a dx here, times your du. Now, what could we do? We could bring the 3 and the over 5 out. X squared e to the 5x dx. Right, so that's going to be, so this expression here, as a function of x, is equivalent to this expression here. They mean the same, but hopefully if we've done a good integration by parts, then we see a nice way, a simple way to integrate our leftover integral here. Right? Because we haven't finished our integration, we've just traded one for another. Well, I notice I've got x squared e to the 5x, which is shockingly similar to what we had before, but notice the 3 has gone down to a 2. And if we think ahead, if we were following along when I explained what was going on with the x cubed, down to the 3x squared, down to the 6x, down to the 6, if we do another integration by parts, we should be able to get this down to just an x, and then down to a constant, and then we'll just be left with integrating e to the 5x, which we already know how to do. Right, so that's the plan. So I need to know how to integrate x squared e to the 5x. Right, so we'll work this out, and then we'll plug it back in here, because we don't want to be dragging around this whole expression here and the minus 3/5 and everything. Okay, so we'll just look at it separately. I will let u be x squared. dv here, now our du, we get 2x dx, and our v, as we've seen before, e to the 5x over 5. So now this expression here means the same as u, v, minus, and now we've got v du. And we could bring out the 2 here and the 5, so we get minus 2/5 x, which is really x to the 1, but we don't write the 1, e to the 5x. So we've done another step. Yes, another integration by parts was needed, but now we've gone from 2 down to 1. So we're almost there. We have one more integration by parts to go, and that can happen. You can have lots of them in sequence. So let's figure out how to integrate x e to the 5x. Right? Once we get that, whatever that is, then we'll have that back in here, and that'll give us this expression without any integration. And then we can plug it back in here. So we'll work all the way backwards. We're just doing things separately so we don't get confused, so it's not too complicated. Right? We're just slowly putting this together. All right, so we'll let u be just our x. That means our du is our dx, and now we finally have no x's left over. dv, we get e to the 5x dx, and so our v is e to the 5x all over 5. Integration by parts says u times v minus v times your du. So x e to the 5x all over 5 minus, we'll bring out the 1/5. And now I still have one integration left to do, integrating e to the 5x, but that's a nice exponential function. We can do a substitution if we really have to, if we haven't caught on at this point what's going on. Right. So we get minus 1/5, and then what do the antiderivatives of e to the 5x look like? E to the 5x over 5. So we get x e to the 5x over 5 minus e to the 5x over 25. Okay. So now we take this. That meant the same as this. These are the same function. Well, we'll tack on our plus c at the very end. So now that can stand in here. So x squared e to the 5x. Okay, we can integrate that to x squared e to the 5x over 5 minus, and then it's 2/5, and then the expression that we just worked out. X e to the 5x over 5 minus e to the 5x over 25. Right? And we can bring the 2, so we get 2x e to the 5x over 25. Distribute the minus sign and the 2/5. We get 2 e to the 5x. 5 times 25 is 125. Okay. So now this expression is an antiderivative for x squared e to the 5x. So now we'll take that and we'll put that in here, distribute the minus 3/5, and at long last we will have the answer to our original question. Right? It's a long process, but it wasn't a particularly complicated process. It was just a sequence of 3 integration by parts. Okay, so what did we have? We had our u, our original v, minus, and that is 3/5. All right, just want to make sure, I don't want to mess it up at the last minute. Okay, and then minus this expression here, so x squared e to the 5x. Now let's make these exponents a little nicer and a little more obvious. X squared e to the 5x over 5 minus 2x e to the 5x over 25 plus 2 e to the 5x over 125. So we get x cubed e to the 5x all over 5. Now let's be very careful and distribute the minus 3/5. So we get minus 3x squared e to the 5x over 5 times 5, so 25. All right, now minus will turn into a plus. 3 and 2 gives me 6x e to the 5x. 5 and 5 is 125. We already knew that. Okay. And now minus and plus gives me another minus. 2 and 3 gives me 6 e to the 5x. 5 times 125. If we really have to, we can do it off on the side. But we get 625. And there we go. Now, since it was an indefinite integral, let's not forget a plus c at the very end. But there we go in all its glory. And it's really interesting, at least mathematically, I would say, to notice patterns. We've got powers of 5 down here. We always have an e to the 5x lurking around. And then what else did we have? Our function, its derivative, its second derivative, its third derivative. Really kind of interesting how it all goes together there. But there we go. We've achieved the answer to our question. Integrate this indefinite integral. Well, all it took was 3 integration by parts, a little patience, and a little organization. But we got it.